Hi everyone and welcome back. It's Kira Garfolo with Greenville Tech's MAT-109. Today we're going to continue real-world applications in section 5.6, where we're going to talk about annuities and loan repayment. Even more than the previous section, this one applies to your future and your everyday, so it can help you make real decisions in real life, and it's not just from a math textbook. Okay. As I said, I really hope you'll use some of this information in your real life to assess, is it a good purchase? Is it a good deal? Do you really want to take this? Should you really borrow this money? We're going to be talking about things like car loans and mortgages and all kinds of things that you can actually think about affecting you and your financial well-being in the future. Remember, we're going to be introducing even more formulas because the last two sections weren't enough formulas, I know, but you have a formula sheet. Make sure you use it. Make sure you practice it and make sure you're familiar with it, and it'll make this exam a breeze. Let's start with ordinary annuities in investing. So in an ordinary annuity, you have a financial plan where equal payments are paid at the end of each period. And in that account, the interest rate is compounded at the same time you make the payments. So a payment's made, the account compounds all at the same time. So if R dollars are contributed at the end of each period and you have N periods, the interest rate of I per period, the future value of the annuity, so what it'll be worth in the future, is S, calculated as what is being paid. R is your amount of payment per period. 1 plus I, so the interest per period, to the N, the number of periods, minus 1 all over I. So again, the important pieces here is to consider N is your number of periods, not necessarily just your number of years. And I is your interest per period, like we saw towards the end of last section. Let's look at an example because that's a pretty abstract formula. Suppose you're paying $100 per month into an ordinary annuity that has a 2% annual interest rate, but it compounds monthly. If you pay into this annuity for 35 years, how much money will you have at the end of those 35 years? Well, we need to consider some things and list what we know. We know that R equals 100 because that's the amount of our each payment. We're making monthly payments for 35 years. So 35 years is 420 months. And the interest rate per period is the annual rate, so 2% divided by 12, which is 0.001667. If you leave it as 0.02 divided by 12 in your calculator, you'll get a slightly different answer from rounding, and that's fine. Just be careful here that you carry multiple decimal places out. Don't round this to 0.002. Carry extra decimal places, extra significant digits, because it's going to have a pretty drastic effect on your answer. Let's plug all of this in. Plugging it in very carefully, we get an answer of $60,759.51. Again, if you round it slightly differently, you're going to get a slightly different answer, but it should be in that ballpark. So you're paying $100 per month for 420 months, and you're going to end up with $60,759. Now, you say, oh, well, that doesn't sound like a lot of money. Well, it grew a good bit. You only invested $42,000 of that. You actually made almost $18,800 in interest. Because again, you only paid $42,000 worth of payments. That extra $18,000, almost $19,000 is extra in interest. So it certainly grew and it made your investments worthwhile. Now let's look at another example. So instead of investing into these annuities, instead of paying money into them so that you have money later, let's talk about you have an investment that's going to pay you a certain amount each period for a set amount of time until it runs out of money. So if you want to receive a payment of R dollars at the end of each period for those N periods, and the interest rate per period is I, just like before, then your lump sum present value investment must follow this formula. Notice it's very similar to our formula before, but we have this negative N up here. Let's look at an example here. So let's say that you want to retire with an annuity that pays you $3,000 per month for 25 years. Okay, so you're banking on needing money for 25 years after retirement, whenever you're going to need it, and you're going to get paid monthly $3,000. Assuming this account earns 4% per year and it's compounding monthly, how much money do you need to invest right now? What's that present value right now of that account so that you can have this situation? Well, we know that R is $3,000 because you want payments of $3,000 each. You know the interest per period is 0.04 divided by 12, which is 0.00333. Same thing, you could carry more decimal places. It'll affect your answer a little bit. And you know that you have a total of 300 periods because 25 years times 12 is 300 months. So for 300 months, you're going to be getting $3,000 every month. If we plug it into our formula here, we see that right now we would need to invest $568,381.23. Again, that sounds like a lot. I don't have $568,000 laying around. I'm sure that most of you don't either. But if you were to put this $568 and some odd $1,000 in, you're actually going to be making, not totally making, but you will be receiving $900,000 total, because for every month for 25 years, you're going to get $3,000. Okay, so you only put 568 in, and you're going to get about 900 out. So it certainly grows and it's certainly worthwhile, but again, it's that whole lump sum thing. Now, something that's a little more probably close to home for all of us right now, loan amortization. So the most common method of repaying a loan is something called amortization. Basically, the lender is going to calculate how much the loan costs. So how much are you borrowing, plus any of the fees that are associated, closing costs, things like that. And then they're going to split that amount into equal payments so that you know your account every month and everything goes on. And at the end of whatever period for your repayment, you're going to owe nothing and it'll be yours outright. So if the debt of A dollars has an interest rate of I per period, and it's amortized by N equal period payments made at the end of each period, then each payment has to follow this formula. Again, you're going to have that formula sheet, so don't worry too much. I, again, is the interest rate per period. N is the total number of periods. And A is the total amount of debt. Okay, so it's, you can think of it as kind of the principal. It's how much is on that account. Let's look here at an example. My animation didn't work, so I apologize. Suppose you want to buy a house that costs $150,000 and you're going to make a 10% down payment and you get a mortgage interest rate of 6%. You're going to make monthly payments and you're going to have a 30-year mortgage. So you're going to make monthly payments for 30 years for this $150,000 house. How much is your monthly payment going to be? Well, first we need to see how much the loan is, right? You're having a down payment, which is 10%. So you're putting $15,000 down because 10% of $150,000 is $15,000. The loan amount then is going to be $135,000. Now we're going to ignore closing fees, anything like that. We're going to say you just owe $135,000. Your interest rate is 6%, but it's paid monthly. So we need to split that 0.06 into 12 for I, which is 0.005. And your number of payments is 12, because 12 per year times 30 years is 360 payments. So you're going to make 360 payments of equal size. If we plug everything into our formula, we get that our payment is going to be $809.39 per month. So you're going to pay $809.39 per month for 30 years. And at the end of 30 years, you'll fully own your house. How much did you pay total? Well, you paid $809.39, or $809,000, goodness, $809.39 for 30 years. So 30 times 12 times 809.39 means that you paid total $291,380 for this house. So the house was $150,000 to begin with. You put $15,000 down, and over the course of your loan, you actually paid $291,380. Only 135% or 135,000 of this is for your house, because remember you already paid 15 down. The rest of it was paid in interest. So you paid $156,380 in interest. You paid more in interest than you did for the house. And that's not uncommon in mortgages, especially rates right now are kind of historically low, but especially not too long ago when they were around 6%. Now that's a lot of money, right? So let's try this again. Let's say instead of getting a 30-year mortgage, you decide to get a 15-year mortgage. You're still going to make the down payment. You still get the rate of 6%, let's say. But now the only thing that's going to change is that you now have a 15-year mortgage. So what is your payment now? Then we're going to talk about the total cost of the loan and how much interest you paid out of that. Pause this and repeat our previous exercise, but now you have a 15-year loan. So now N is 180 because 12 months times 15 years. Okay, we're not doing 12 times 30 anymore. We're doing 12 times 15. We still have $135,000 for the loan. 0.005 is going to be our interest rate, or our I per period. And if we plug all of this in, we see that our new payment is $1,139.21. So our payment certainly went up, right? It went up from $809 roughly to $1,139. So it's still an extra, what is that, $300 and something a month. But you pay your house off in half of the time. The total cost of the loan then is going to be $1,139.21 times those 180 months, because that's how many times you're paying it. Instead of $360, you're only paying it $180. So the total cost of the loan is $205,057.80. Subtracting $135,000, only $70,000 of this is in interest. So before, remember, we paid $156,000 in interest and changing nothing except making it a 15-year loan. We increased our payments, but we didn't double them. And we saved a lot of money in interest. So sometimes that's your better option. So in conclusion, make sure you use your formula sheets, okay? You have it, all of them are there. Again, you want to be very familiar. Read each problem carefully. There's a lot of information given, but you need to write down each variable, know what they're asking, and think about your compounding and payment periods. How many payment periods do you have? What does that do to your interest? Are you talking annual, quarterly, monthly? What are you talking about? And you need to make sure that you divide your interest accordingly for all of these formulas. I is not necessarily your annual rate unless you're making annual payments. I is going to be divided by those number of periods. As always, practice, practice, practice. It's very important in this section to practice. But again, this is very realistic, very applicable real world stuff that can help. As always, thanks for tuning in, and I hope to see you next time.